And this is, let me write down the question here. This is the question. F1s. So if you see this, we have to find out the inverse Laplace transform. If you see the denominator, roots are discrete. Okay, how do you find the roots of the factor? You just equate the factor equal to 0. So this factor is s plus 1, equate it to 0, you get s equals to -1. Similarly, s plus 3 equals to 0, you get s equals to -3. So these, if you see the two discrete roots, then you can solve this method quite easily. The way you have to do the partial fraction expansion. So a is the partial fraction coefficient. You will, I believe you have done the partial fraction expansion before. So the left hand side is this one. So in order to find out a, how would you find out a? The way you will find out, look at the denominator of a, which is s plus 1. So you will multiply the whole, both sides, multiply both sides by the denominator of a, by the denominator of a, and evaluate at s equals to -1. So let's multiply on the left hand side. If I multiply the left hand side, s plus 5 over s plus 3, because the other factor gets cancels out, so I don't need to write it down. So a plus b, and plus one more thing over here I want to mention here. So when you do the left hand side, you have to equate this equals to, you have to evaluate the left hand side, right hand side with the this is s plus 1 over s plus 3. Evaluate at s equals to -1. I will show you two ways. Yes, first of all, let's see this easier way, and then a equals to, so once you evaluate the left hand side, the right hand, this goes to 0. Okay, once you evaluate, this goes to 0. So the right hand side is a, the left hand side is 5 minus 1, which is 4, 3 minus 1, which is 2. So a equals to 2. Similarly, you will do the same thing for the other coefficient b. So in order to find out these coefficients, the first thing is to find these coefficients, and the way I'm explaining you how to find this. So for b, let's find out b. How would you find? You will see the denominator of b, you will multiply both sides by s plus 3, s plus 5 divided by s plus 1. Now you will evaluate with this s equals to -3, and here the left hand side a becomes 0, because once you evaluate s plus 3 at s equals to -3, it will 0. So b is left only. So b equals to 5 minus 3, which is 2, 1 minus 3, which is -2. Do you guys understand how did I expand this partial fraction coefficient? This is known as partial fraction expansion. Now we will write this factor down. The left hand side, we will write this down like this, and that is equal to, now what we have to plug in the values of a and b. A equals to 2 divided by s plus 1 minus, I would say, you can just don't get confused, it is plus sign with the, but the negative sign comes from the b, s plus 3. So if you do the inverse Laplace, so in order to do the inverse Laplace, you have to understand there is a table. So let me show you the table. If I go to Ogata book, Yes, this is the table. So if I cut and paste this table, not whole, but you can just see, let me cut and paste a little bit more. Now you have to see the left hand side is the time domain. This is the time domain, and this column is the Laplace domain. So when you go from time to Laplace, time is, as you can see, is time is in second, Laplace is in hertz, or the it is in frequency domain. So you will see that this kind of expression, one is not like this is not like this not. So this is the same form like 1 over s plus a. So if we go inverse Laplace, so you have to find out the denominator. Usually the denominator is the main thing. So s plus a, you see over here, it is, what is a in the first term? It is equal to 1, correct? So 2 will be the scaling factor, so 2 comes out, and e to the, you see, what is e to the negative a? E to the t, because a is t. For this one it is negative 1. I would not write down 1, I will just keep it like this, negative e to the negative 3t. This is your answer. This is f of t. So when you go from Laplace to inverse Laplace, you come to the time domain.